This video focuses on the fallacy of division, and we're going to cover a number of different topics in this video. We're going to talk about what the fallacy of division is. We'll look at the structure of the arguments involved. We'll talk about why it's a fallacy. Then we'll look at some common situations in which you can expect people to be making or committing this fallacy. We'll look at 3 examples of the fallacy. If you want to see other examples, I'll be uploading videos just full of examples for you. We'll talk about how to spot it in its native habitat. We'll talk about what this fallacy gets mistaken for, and we'll finish by talking about how to avoid committing this fallacy in your own thinking, reasoning, argumentation, and communicating. So what is the fallacy of division? In its essence, what it consists in is arguing that because some whole that is composed of parts possesses a property, all or some of those parts likewise possess that same property. And it's only a fallacy when that's not really the case, or we have no reason to suppose that it's the case, especially with that particular property. So, what structure does this fallacy have? You can have basically 2 premises and reach this conclusion. And if those premises were actually true, then that conclusion would follow from it. But one of the premises is not actually true. And you notice I've got it in brackets there. It's usually an implicit premise. The person is not making this explicit. They may, in fact, come out and make it explicit. That makes it easier to diagnose the fallacy and to break it down. The way it works is the first premise says this whole that we're looking at has property X. X could be whatever we like. And we're adding another premise into it, and this is the weak point in the argument. When a whole that is composed of parts has a property, the parts also have that property. And we've got good reason to think that's not always the case, but it's being assumed as being true in this case. So the conclusion then is that a part or parts B have that very same property that the larger whole possesses. Now, this is in technical terms, a deductive argument where one of the premises is actually false. So this would be an unsound deductive argument. If it was actually sound, then it would be a valid deductive argument, but it's not sound. Going on and looking at the structure, we can represent this graphically. We're reasoning from the whole, and we're saying that that has property X, and we're saying that each of these parts has property X. Or we might just be talking about one part or, a subset of those parts, but we're saying that we can draw an inference, and that's why the arrow is running from whole to parts. We can draw an inference from the fact that the whole has that property to the parts having it. Now, why is it a fallacy? Well, some properties can actually belong to a whole without therefore belonging to the parts that compose or make up that whole. We need to look at each property to see whether it's the sort of thing that we can actually say about both of these on both of these levels. In many cases, a whole is in fact more than just the sum of its parts. It has features which parts on their own don't have. Think about your body, for example. Cut it up into its constituent parts, and it's not going to work very well. It's no longer living, right? So there are wholes that have properties that you can't sort of trickle down into the parts. What are common situations where we can see this happening? Well, the fallacy of division is going to occur when we're reasoning about wholes and their parts and their properties, and we're not being careful. So what are examples of wholes composed of parts? Compositions, like a book, or a musical score, or a meal. Organic bodies, machines or mechanisms, organizations or teams, collections, institutions, movements, countries. All of these are good examples of wholes. And then what would be the parts of them? They could be members or organs or portions, segments. They might even be smaller wholes or subsets of that larger whole. So when we think about these sorts of things, that's when this fallacy is likely to occur. Let's look at some examples now. So one interesting example, a musical album. This is quite frequent, where a band will bring out an album and you say, I'm going to buy it because the album as a whole is really great. And I'm, using the example of heavy metal here because I'm into heavy metal. So, what would be criteria for that? It's a great album. It's a classic album. It's hard rocking. It's very heavy. Pick whatever you like. Therefore, every single song on the album is a great hard rocking heavy metal classic. You can't say that about certain albums. As a matter of fact, I can think of a few where there'll be one song on there and you're like, how the hell did that get on there? That's awful. That's not like them at all. Usually, in my case, it's a ballad. But, there's other surprises along those lines. And now notice, why is this an example of the fallacy of division? You're reasoning from the larger unity that is a composition, the album as a whole, and you're reasoning now about all of its parts, and you're saying that all those parts possess the same characteristic as the album itself. Another example would be an automobile, and this you could say about many other things as well. This is one you can easily see is a fallacious argument. My car is way too heavy for me to possibly lift. That's a true statement. Now, does that mean that the conclusion follows that each part of my car is way too heavy for me to possibly lift? Clearly not the case, right? What about your rear view mirror if you took it off? Is that too heavy for you to lift? It's a part of your car. No, it's not too heavy. So clearly there are some characteristics that are possessed by the whole, and they're possessed in part because the whole is put together at all these parts, which might not be all that heavy in and of themselves, but when you put them together, they become too heavy for you to lift. Some parts probably are too heavy for you to lift, the transmission. But, if you broke the transmission down into its constituents, and depending on how weak you are, you probably could lift most of those. Okay, let's look at the third example now. A restaurant. So this restaurant provides excellent, innovative, tasty cuisine. Therefore, the dishwashers provide excellent, innovative, tasty cuisine. No, that's not true. The dishwashers provide hopefully clean dishes that the cuisine can be placed upon, plated, served, eaten, and then go back to the dish room where they get washed again. So this is an example of an organization, we could say, or a team. Not everybody on the team possesses the qualities that the team itself can be said to possess. How do you spot this fallacy of division? So when you see arguments being made going from the whole composed of parts down to those parts, you want to pay close attention to the property about which the claims are being made. Keep an eye out for cases in which what's true on one level, that is the higher level, is not necessarily true on the other level, that is that of the parts. Or put in other terms, pay attention to cases where the whole really is more than just the sum of its parts. Let's talk now about what's not the fallacy of division. So, in my experience, there's only one other fallacy that students frequently will mix up with the fallacy of division, and that's the fallacy of composition. Fallacy of composition goes the exact opposite direction in relation to parts and wholes as the fallacy of division. So since they both deal with parts and wholes, it's easy to see why one might get mixed up about them. The way to keep this in mind is when we're going from the whole to the parts, we're dividing the whole up into its constituents. And when we're going from the parts to the whole, we are composing the parts into a greater unity that is a whole. So that's one way to keep from blurring these two together. Now, not every argument that's going from the whole to the parts is actually going to be a fallacious argument. You want to stay on guard once you've started to diagnose fallacies and identify them. You want to stay on guard from the tendency to see them everywhere. There are many cases where we can, in fact, generalize from what we know about a whole down to its constituent parts. For example, when we make inferences about a glass of water, saying that because, the glass is wet, the whole glass of water, each gulp of it is going to be wet, that's actually correct. So we don't want to say, aha, somebody's committed a fallacy there. And there's a lot of other cases where we can say things about the individual members, constituents, parts, because we do know something about the whole. Now, how do you avoid falling into the fallacy of division when you're engaging in your own reasoning, your own argument creation, when you're making a case to other people? So when you're reasoning from wholes to the parts comprising that whole, ask yourself, is the property that I'm making a claim about something that's always or usually true of a part because it's true of the whole to which it belongs? That's an important criterion. And keep in mind what being brought together into certain kinds of wholes actually adds to the parts. There are some properties that are what we call emergent, with which the whole is more than just the sum of its parts. So if we're dealing with that kind of property, then you have to be careful about what you're saying about the parts based on the evidence of what you know about the whole, because you might be falling into this fallacy of division. The last thing that I'll say is that this video is part of a much larger series discussing common fallacies in reasoning and argument. It belongs to a channel devoted specifically to critical thinking, reasoning and logic, and argumentation. So if you enjoy this video or you find it useful, share it with other people, and check out the other videos and series that are offered in this channel.